Solve Leetcode question 15, threesome, and give an integer array of nums, return all triplets, basically three number from this array list, such that they don't equal, they are different numbers. I does not equals to j, none of them are the same numbers, and all three numbers adds up to 0. In this case, know that the solution set must not contain duplicate triplets. So if they are you can't return the same three numbers again. That's basically. And if you look at the example here, the minus 1 2 adds up to 0, right? And the minus 1 0 1 adds up to 0. There are two minus 1 here. They're not really duplicates. That's because there are two minus 1 here in this case. So there's if the nums is empty, then you return empty. If it's 0, and then you can just return empty in this case. There are some constraints here, and here are the company asked this question in the last 6 months, and you can see Amazon asked this question 46 times in the last 6 months. So if you remember how we solved the two-sum, the two-sum is basically we use a hash map to check the key and the value, and the key is basically the key is the nums, and the value is basically the index, right? In this case, threesome, one thing really important before you do the threesome is it will be super helpful for us to actually using our array of nums that is actually sorted, because when the numbers are sorted, then we will know how do we pick the three numbers more efficiently instead of brute force it. If we brute force it, then we will have to start from the first number and then calculate the second number and the third number, and basically continue to shift, and the algorithm could get really inefficient. But if we have sort the number first and minus 1, right? And then we do 0 and 1, 2, 1 2 0 and a minus 1 and a minus 4 in this case. So basically, if there's 6 numbers here, how we do it is that we're gonna still do the same thing after we sort the array, and we still do the same thing to start from the first number, pick it as I, since we will have to pick three triplets here in this case. We will start checking the rest of the array by doing picking the number right next to the I as the left pointer, and the last number, I'm gonna start the right side of the pointer. The reason is because this is like a binary search. It's basically, if I want to add all three numbers to 0, if I remain to be the same, and I'm just gonna continue to shift left and right until I find the three numbers adds up to 0. And the reason it's super helpful to sort the array is because if the three numbers adds up together, if it's too big, that means that all the bigger numbers on the right side, then I need to shift the right array to one thing smaller to the left side, right? And if the number is too small, then I know for sure that what I need to do is increase the sum. And since the numbers are all sorted, I just need to continue to shift the left pointer to the right side. If I, during the process, let's say if I have an I and let's say I is at minus 1, right? If I have an I and then I found the left array, the left is minus 1 and the right is at 2. If I find this combo, I'm constantly checking, and if it's add up to 0 already, I'm just simply append these three numbers to the result, because this is one of the solution, right? And after I find the answer, and I'm gonna continue to shift the I and the shift left and the right to find other combo. Once I go through the left and right to the entire array as I, basically minus the last two number, because in the last case scenario that you will need to save the last two number, one as left and one as right. And basically if I have moved I to this position and left and right to this position, that means I have already checked every single possibility, and then I'm just gonna return the final result. Every single triplets that meet this requirement, that I'm just gonna return all the combination, which is really efficient. This is like a two-pointer method. Basically, you use one you while you iterate the I, and then you check the left pointer and the right pointer, and the time complexity the is n squared, because the sorting the array take n log n time, and overall time complexity is n squared plus n log n. So that's basically equivalent to n squared in this case. And space complexity is from O log n to ON, depending on the implementation of the sorting algorithm. So yeah, that's pretty much it. And let me show you how to do this in code. Basically, I'm gonna set a result array here, and I'm gonna sort the nums here. And basically, after I sort the nums array, it will look something like this. And then I'm gonna say for I in range, I'm still gonna go focus on I and go through I and nums -2. And the reason I -2 I already showed you, right? Because I have to leave the last two as one left pointer and the one as the right pointer. So I only need to go to this number instead of the end of the array. That's why you have to -2. So if I is bigger than 0, and then nums I is equal to nums I -1. So if the nums, if the I, because it doesn't allow duplicates, and if two numbers are the same, if nums I is same as the previous number, we already checked that. I'm just gonna continue in that case. And then otherwise, I'm gonna assign the left and the right pointer. The left pointer will be always starting from I plus 1, right? The right pointer will start from the end of the array, basically, which is length of nums -1, right? So I'm gonna checking by using two pointer, and while left smaller than right, because left, you don't need left equals to right or bigger than right. In that case, it's the situation you already checked. You don't need to check it anymore. That's the while loop that we have to go through. And basically, how the three sum numbers adds up together is nums I plus nums left, right, and then plus nums right. So these are the total of three numbers together. It wants you to add up to 0, right? So here I'm gonna do condition check. If the three sum is bigger than 0, I'm gonna shift the right pointer. That means the number is too big, bigger than the result we're looking for. So I'm gonna shift the right pointer to left side. And elif, if the three sum is smaller than 0, that means the sum is too small, then I'm gonna shift the left pointer. I'm gonna shift the left pointer to the right side to increase the total value. Else is the condition if the three sum is equals to 0. If the three number adds up exactly to what we're looking for already. I'm just gonna append. I'm just gonna append this three numbers, basically nums I, nums left, and then nums right to the final answer, right? And then the other condition that we need to check to rule out is if while left is smaller than right, and then also left equals to nums L plus 1, that's to rule out if there's any duplicates. We don't want any duplicates. And then we wanted to L plus 1. So we just skip if we find anything that is bigger. If we find anything that is same on the for the left pointer is the same as the next number, then we basically just shifted the pointer to one more right. And the same thing, we're gonna do the right side if there's any duplicates here. So if the right side equals to nums right minus 1 on the left side, and then right needs to minus 1 here. In either case, we're going to shift the pointer until there's no duplicates. We're still going to continue to look for the rest of the nums that meet all these requirements, right? What we do is that basically I'll left pointer shift 1 to the right, and the right pointer shift 1 to the left side. And then I'm going to continue to search for the combo that meets the requirement. And in the end, I'm just going to return the result. That should be what we're looking for here. Yep. And that got accepted. And yep. If you think this video is helpful, please like my video and subscribe to my channel, and I'll see you soon with more Leetcode questions. Bye bye.